Ha ha ha, it me. Today we're going to be looking at a nice little kind of workaround for an issue that a few people have kind of come to me about that are using the sort of material masking method that we looked at in this video here. It's the video about combining all of your material slots into one material slot. But with that out of the way, let's just jump straight in to our session. The problem is that when you do a line trace or a hit result or something, the physical material won't care about what the colors are and what the textures are and all that kind of stuff. Now, Unreal kind of looks like it used to have a method to do this using color masks, which is a bit yikesy. So we just search fizz in here. Then you can see that there used to be a physical material mask, physical material map, and it seems like it isn't very flexible at all. And also there's only, eight channels, and I think it required having a texture for every asset, which is a bit sussy-wuss. So what we are going to be doing is we are going to be kind of creating our own, physical material sectioning system. So here's what we're going to be using as an example. We have some, roof tiles here. We've got some wood here, and we've got some, concrete/stone here. And let's say we shoot an arrow or something, and if the arrow hits the wood, we want it to stick in the wood, and if it hits, the tiles or this, we want it to, bounce off and spawn some particles and spawn different particles when it hits the wood. You get the point. And we also want this system to work with things like the landscape, because the landscape can output a physical material, and that's really useful for things like playing, footstep sounds and particles and all that kind of stuff. Now, just to recap how we are actually doing this kind of, material sectioning, material ID map thingo, we have our regular UV channel, which looks like a, bit of a mess. That's because it's using tiling textures and they can go outside of UV bounds and blah, 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 blah. But in our second UV channel, we have, let me just take a little screenshot of this. Basically, we've just separated this into strips. And if something is placed in a certain strip, we can then do a blend in the material and assign a different texture, different color, different, everything. And so we can actually use that to our advantage. And that is what we are just about to do. But before we do that, a quick word about today's video sponsor, Skillshare. Skillshare is an online learning platform where you can learn absolutely any skill that you may desire. As game developers, I think it's always a good idea to keep in mind that the people that are going to be playing our games aren't necessarily other game developers. So I personally put a lot of effort into, learning visual design, learning about color, 3D modeling, writing, audio design, music, all of these things that the vast majority of players are going to take in and appreciate. If you'd like to join me and the many, many others utilizing Skillshare, you can enter the code PrismaticaDev at sign up or follow the link in the description to get 1 free month of Skillshare. So I hope to see you all there, and one more big shout out to Skillshare for sponsoring today's video. We are going to create a blueprint function library. I'm going to call this tutorial library. Now, a blueprint function library is simply just a library of functions that can be accessed anywhere in your project. So what we are going to be doing is creating a function, and it's going to be called get. We're going to be using fizz material from hit. We are going to go blueprint class. We are going to go data asset, primary data asset. We hit select. We are going to call this our material fizz material whatever. And another thing we're going to need to do is we are going to need to make a new struct. Now, this is kind of a little bit hacky because we're going to be creating a map. So we're going to map our material instance, or I think it's called a material interface technically. And we're going to map that to an array of values. Now, by default, for some reason, I think it's only a blueprint restriction, you can't map a value or a key to an array as its value. So what we're going to do is we're going to kind of hide the array in a struct because you can map to a struct. So just roll with it. So we're going to call this our physmat array. And this struct is just going to be physmat array. It is going to be an array of physical materials, object references, and then we're going to click this one. We're going to make it an array. We're going to hit save. All right, now let's go back to our primary data asset. We are going to add a new variable to this, and it is going to be our material to physmat map. And what this is going to be is a material interface. A material interface is, it includes both a master material and material instances that you've created in editor. So you might be just applying a master material straight to something, or you might be applying a material instance of a master material to something. So this includes both of them. Just chill. And then we are going to turn this into a map, and we're going to map it to our physmat array. Ooh, there it is. Cool. Now, let's right-click again. We're going to go miscellaneous. We're going to go data asset. And this is going to be our material, phys, material, whatever you called your primary data asset. And we're just going to call this material, phys, material, map, asset. Call it whatever you want. So let's click on this. And now we can start populating our material thingo. And then when we click this one, we can now make an array of physical materials. So for example, if we go to this, what we will do is I'm going to go into the actual material instance because it just makes it easier to see what these are all made of. And if we look here, just judging by the color number 1, 11, and 12 are all stone. So we're going to go and find our material instance, castle, roof, bluestone. And in fact, I think what we'll do is we'll actually leave the first one blank all the time, just so it's easier, because obviously arrays start at index 0, and then, you know, whatever. So just for the sake of making it easier, we're going to leave 0 empty, and we're just going to say stone, and then stone here, and stone here. I believe 3 was wood, 4 was the tiles, 6 is metal, 4 can be probably just stone again, and 6 is going to be metal. And now what we've done is we have mapped our material instance thingo, and we've mapped it to an array of physical materials based on the UV placement of the second channel. So the next step is going to be actually building this function. Now it will need to take in input a hit result. So we're going to go to hit result, bam. We've now got a hit result. And from this hit result, we're going to break. From this, we are going to get our hit component. So this will be a static mesh, ideally. And we are going to get its material. And then what we will be doing is, let's create a new input. And this is going to be our material, phys, material, whatever you call your primary data asset. And that's going to be an object reference. So essentially what's going to happen is when you call this function now, let's just make an empty blueprint. Let's call get phys material from hit from our library. And we can just say there's only going to be one thing here. We just click that, and that's going to send in that data asset ready to be used whenever we call this function. So we are going to get our phys material map. And if you're wondering where this came from, because we didn't create a variable, you can get inputs as local variables without actually setting them first. And then in here, we are going to get the map. In this map, we are going to find, and we are going to find and see if the hit material is in this. And if it is, then we continue on. And this is where we're going to do some other stuff. And then you may want to, if the material isn't included in our map, you might want to do something instead. Let's just make a return node here. And we're going to be returning a phys material, obviously. And in this case, we might just want to get the physical material from the thing that we hit, presuming that a physical material was set on either the static mesh or the material itself. And we're just going to do an isValid check on here. And if that was false and this is valid, we want to return this bad boy. And then if there was no physical material to be found on the asset, then what are we going to do? Well, you're just going to return, I don't know, a default one. Or none. You could just return none and deal with that on the other end. However, if we do find something in our map, so, we found this material on the thing that we hit, we are going to do some mathematics. Now, the first thing that we're going to have to do is a line trace by Chanel. And the reason we have to do another line trace, because obviously we're taking a hit in here, so you might have done a line trace, hit a static mesh, and then put that hit into here. But ideally, you'll never be tracing against complex collision. So this assumes that we did a simple collision trace, then we've hit something. If we found the material in the material map, now we're going to do a complex trace. And the reason we're going to be doing a complex trace is because we need to do a function called get UV. Oh, it's called UV from... No, it's called find collision UV. And it needs a complex collisionator. The other thing we're going to do is we are going to... Let's just get our hit from the beginning of the function. So that's this one here. And we're going to break again. And we're just going to do a little bit of vector math. So we've done a trace, we've hit something, and now we just want to do another little trace to just like hit where it hit. We are going to get the start trace and the trace end. Then we're going to normalize this. This is going to give us the direction that the trace is moving as just like a unit vector. And then let's just say multiply this by... Oh god, I hate Unreal 5 and the thingo. So, convert pin, float. Multiply this by, I don't know, 50 will probably be enough for 99.9% of cases. And then for the start location, we're going to get the impact point plus this. And for the end location, we're going to get the impact point minus this. And so basically what that's going to do is, let's just draw it out in paint. So here's the thing that we're hitting. And our line trace hit like this. And what this is going to do, it's going to get this point. And it's going to say, this is the direction. Let's move 50 units back this way and start here. And 50 units this way. And we're going to do a trace like, let's do it in blue, like this. And it will hit the thing. Now, the reason we do this little bit here is because the simple collision might look different from the actual geometry of the mesh. So maybe the actual geometry looks like, you know, this. It's like some brick pattern, whatever. And if, you know, if this wasn't long enough, then it might not actually hit it. And that being said, if there was some, you know, geometry that was extruding past the collision and we started it from inside, then it would also, you know, not actually collide with the complex collision. Anyway, I digress. All right, we are moving on. So we should have hit a complex collision doodad of the mesh that we're looking for. What we will do now is use this function. We're going to be looking for UV channel 1, which is our second UV channel, whatever one you're using the material map on. Then we're going to break this bad boy apart. And because we have our UVs aligned in, you know, vertical strips, we're only concerned with the x-axis. Now I'm going to multiply this by 16, because I have 16 channels in my thingo, and then we will seal the result. So that little doodad there is basically just saying, here's our UV thingo. It's split up into sections like this, and all of our little UVs are just in like little clumps, you know, wherever. We're gonna hit our model. We hit, where is this UV, where's, you know, this vert on our UV map? Well, it's over here, right here. And that little bit of math we did is just gonna say, okay, well, this is in slot number 3. You know, it's somewhere in here. So what we do now is we're gonna go back to here where we found our array thingo in here. We are just gonna right click, split this. We're gonna grab the resulting array that we found in the map, and we are gonna get the physical material that we put in this array that's numbered accordingly to the kind of section that it's at. Then we're going to get our return node, chuck this here. You might want to just do this in case the what's it called? In case the complex trace doesn't hit for whatever reason. So let's just do a branch, and out of the false end, I would probably just write myself like an angry message saying, hey, you cocked something up, you know, you just check out this thing, you messed it up. But anyway, if all that succeeds, we get the UV, blah, 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 we do the math, we get from the array the result, and we chuck that into here. Wow. Now, there is one more little, I guess, complication, which we will go over. And that is if the material that was hit is a dynamic material instance. So in that case, we are going to cast to material instance dynamic. We're going to convert this to a pure cast. Then from here, we're going to do a select. And then with this select, we are going to get the material instance dynamic. We are going to get the parent, which is like the material instance that it is derived from. And we're going to chuck that into true. And then if this wasn't a material instance dynamic, we're just going to get the material, put that into the false. And then this is going to go into the map. And then we just do all our other stuff as normal. Alrighty, let's do ourselves a test. So when I hit P, if we hit the ground, it should say grass. If I shoot over here, it will say sand. This is just regular, you know, landscape material output, blah, 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 blah. But this asset here, as we explored earlier, has only one material, but we've now included its material instance in our kind of global data asset that says this material has these physical materials at these parts of its UVs. So now if I hit here, it should say stone. Yep. Oh, well, there, apparently. That's also stone. If we hit here, it should say stone. But if we hit here, it says wood. Woohoo! Now, isn't that something spicy? So, there we have it. We can now get physical material from the doodad with the thing, with the stuff, and it works. It just works. Now, keep in mind, this won't work with skeletal deedle meshes, because scaly meshes can't, use this function. Also note that in the tooltip here, it says try and find the UV for a collision impact. Note this only works if support UV from hit results is enabled in physics settings. So you will have to enable that in your project settings. And as always, if you have any questions or you think I've missed something or you want me to clarify something, please leave a comment in the comments below. Comment. Lastly, before we wrap up, I just want to say that this is something that I first built on Twitch, live on stream, in the flesh, kind of. I have been streaming a lot lately, streaming development of Prismatica, the game, which is why I haven't kind of uploaded in, about a month or so. So apologies for that, but I'm not sorry. But I just thought I'd mention that if you're looking for more Prismatica content stuff, Twitch is, where you can get your fix. And lastly, but not leastly, I do want to thank the lovely Patreon patrons for their continued support. You guys are fantastic. If you would also like to become a patron for as little as $1 per month, you can do so through a link in the description. And I guess with that, we say goodbye. Goodbye.